The objective today is to go over the logical bit and byte instructions. And you already know I'll have these questions ready for you in each of these chapter 5 sections we're doing. So let's begin by naming 5 binary and decimal instructions you remember from the last video. And then we know at the end I'll go ahead and ask for examples of the logical bit and byte instructions that we study here in this video. Now before I begin, this picture right here, there's got to be a metaphor. Maybe this is a core dump. Maybe it's the instructions that lead to a buffer overflow, but just thought I'd share that with you. Alright, here we go, and we're on page 114. It says the logical instructions perform basic and or XOR and not logical operations on byte, word, and double word values. So at this point, if you're watching these videos, you really should know what these logic gates are doing at the low level. And logic gates are created by transistors. So we take a bunch of transistors, wire them together in a certain way, and then when we put things, input things, two things into the AND, we know what will come out. A 1 and a 1 will output a 1. Anything else will output a 0. So it's neat that you can literally type these in as instructions and the computer will follow them, and in an inception, like dream within a dream situation, at the lowest level those logical gates are being used. Now I don't see all the logic gates here, like what about the NAND one? Is it that Intel would want you to put the NOT? Is it that Intel would just want you to use these in a combination to create whatever output you're looking for? If you want to go on a journey though, here's a good question. The question is, what kind of logical instructions are used for bit masking, for cryptography? You could go on a little Google search to look at that stuff, especially for this one. I'm thinking you'll end up on Stack Overflow. And once you get there, you'll see why this is kind of a trick question from me. But let's stick to the Intel manual here. It says section 515 is all about shift and rotate instructions. These instructions shift and rotate the bits in words and double word operands. Let's start with the SAR instruction. This stands for Shift Arithmetic Right. SHR, Shift Logical Right. SAL is the same as SHL. That is, you're going to shift arithmetic left, unless you wanted to think about it as if you're doing a logical left shift. We could also shift right by double, shift left by double. We could rotate right, rotate left, rotate through carry right, and rotate through carry left. Now I think these are going to get increasingly harder to find in the wild. And I even added an extra write those down and a bonus for explaining what you're seeing right there. Even if you're just using the coffee pot example to begin narrating assembly code, I think that might be worth your time. But of course, just take these lessons really relaxed. I'm just trying to add another way to learn these really difficult things. Just doing my little part in adding to the summation of all human knowledge. Well, our last set of instructions, that's funny to say, our last subgroup of instructions is the bit and byte ones. These test and modify individual bits in word and double word operands. Now, byte instructions set the value of a byte operand to indicate the status of flags in the eFlags register. So a good question is, what do the bit and byte instructions work with? It's working with the eFlags register. That's really cool and completely relates to all our talk about the exception handlers. Okay, so we got BT for bit test, BTS, not a band that my daughter likes, but BTS is bit test and set. We got bit test and reset, bit test and complement, bit scan forward, bit scan reverse, set byte if the equal. Of course, we got the same thing in set byte if 0. And we actually got a lot of those scenarios, so skipping reading that there. We could set the byte if the sign is negative. We could set the byte if the sign is not negative, aka positive. We could set a byte if there's an overflow, set a byte if not overflow. Was I reading these as bits? I'm sorry. So there's setting bits and there's setting bytes. Just keep that separate in your mind. So we'll finish with set byte if parity even, set byte if parity odd. We could straight up test, which is cool for a logical compare. And then we have the CRC32. This provides hardware acceleration to calculate cyclic redundancy checks for fast and efficient implementation of data integrity protocols. When I teach my students about cyclic redundancy checks, I usually use barcodes as an example, and I have that video out there. I'll provide a link to it in the description here. But cyclic redundancy checks are pretty cool. Our last instruction for the day is a pop CNT. This instruction calculates of number of bits. Ooh, a typo. This instruction calculates of number of bits set to 1 in the second operand. They say source, I think coffee pot. And then it returns the count in the first operand, which is the destination register. Not destination memory, huh? Well, okay, that's it for today's video. Let's ask one more question. Which instruction stood out to you today? And with that said, next time we'll talk about control transfer instructions. That one's a decent sized. Then in string instructions, I think I'll fit those two into the next video. So a quick reminder that a good way to maybe start memorizing all these instructions is, first of all, use tiny cards. I've made several of them myself. You could just search for the type of instructions you're looking for, like data transfer instructions, and those are already created for you. So to me, it's kind of just a lazy way to start getting into this stuff. We can't all spend massive amounts of brain power working through the code, especially if you're just starting out with this. And I do suggest people start out at this level for programming because I think it makes the higher levels easier. And then my second strategy for learning is you could look at something like this Intel manual and you just write down the instructions yourself. And then, without looking, try to comment what they mean using just the mnemonics. So not looking at this part, I meant. Well, this is just a reminder I'll put at the end of each video, and of course I'm going to always thank you for watching and learning with me.